Welcome back to the channel. In this video we'll look at the solution to questions 7 and 8 in the combustion and thermal decomposition series. So let's get started. Here's question 7. What volume of gas is produced when 300 grams of ammonium carbonate thermally decomposes? So let's start off with the molecular formula for ammonium carbonate. We've got the ammonium ion, NH4+, and the carbonate ion, CO3, 2-. To balance the charges, we're going to have 2 of the NH4+, so we've got 2+ to balance the 2-. So the formula is going to be NH42CO3. That's the molecular formula. Now, when we heat up solid ammonium carbonate, in fact we get 3 gases. We get ammonia, carbon dioxide, and steam. So there we are. We need to balance that equation. So starting with the nitrogen, we've got 2 nitrogen atoms on the left there, and so we're going to need 2 in front of the NH3 on the right to get 2 nitrogen atoms on the right. Looking at the hydrogen, we've got 4 times 2, 8 on the left. On the right, we've got 2 times 3, 6 in the ammonia there, NH3, and 2 more in the steam, H2O, so 6 plus 2, 8. The hydrogen is balanced. The carbon is clearly balanced. We've got 1 each side, 1 atom each side, and the oxygen, we've got 3 on the left there in the CO3. On the right, we've got 2 in the CO2 and a further 1 in the H2O. So 2 plus 1, 3, the oxygen also balances. So now, if we look at the equation, we can see that 1 mole of ammonium carbonate, when we heat it up, we get 2 moles of ammonia, so that's 2, 1 mole of carbon dioxide, another 1 of gas, and 1 of steam. So the total moles of gas we get are 2 plus 1 is 4. Now, each mole of gas occupies 24 cubic decimeters in volume. So if we've got 4 moles, we're going to have 4 times 24, 96 cubic decimeters. So therefore we heat up solid ammonium carbonate, 1 mole of it, we're going to get 96 cubic decimeters of gas in total. But we've got 300 grams of ammonium carbonate, so we need to work out how many moles that is. So first of all, we want the molar mass, so let's do it. We've got 2 nitrogen atoms, so 2 times 14, 14 the atomic mass of nitrogen. Add on 8 times 1, we've got 8 hydrogen atoms, each got an atomic mass of 1. We add on 12, the atomic mass of carbon, we've only got 1 atom of that. And we've got 3 of oxygen, so 3 times 16, 16 the atomic mass of oxygen. If we add up all those figures, we get 96 grams. So that means if we heat up 1 mole, in other words 96 grams of ammonium carbonate, when it decomposes, we get a total of 96 cubic decimeters of gas. So if we divide everything by 96 to get 1 gram, then we have to do the same on the right, and that's going to produce 96 over 96, 1 gram of gas. But we've got 300 grams, so multiply up by 300, do the same on the right, and we're going to get 300 cubic decimeters of gas, which is answer D there. So now let's go to question 8. Which of the following produces the largest mass of gas when thermally decomposed? So we need to take each of these in turn and work out what mass of gas we get. So we start with the lithium carbonate. So we need the formula. Lithium is in group 1. So it produces the Li plus ion. Carbonate is CO3, 2-. And to balance the charges, we're going to need 2 of the lithium, so we've got 2+ to balance the 2-. So we've got Li2CO3. Now, when we heat this up, it will thermally decompose to produce the oxide, lithium oxide and carbon dioxide. So there's the equation. And I think we can see this is already balanced. The lithium there, we've got 2 atoms each side, the carbon 1 each side, and the oxygen we've got 3 on the left and 1 plus 2, 3 on the right. So everything good there. So from the equation we see that the thermal combustion of 1 mole of lithium carbonate is going to give us 1 mole of the gas, the CO2. But we've got 100 grams of lithium carbonate, so we need to find out how many moles that is. So first of all, get the molar mass of lithium carbonate. It's going to be 2 lots of 6.94 is the atomic mass of lithium. So we need 2 lots of that because we've got 2 atoms of lithium. Add on 12 for the 1 atom of carbon, and 3 times 16, 16 the atomic mass of oxygen. Adding everything up, we get 73.88 grams. So now we need to look to see what mass of gas we get. So the molar mass of CO2, that's 12 for the carbon, 2 times 16, 16 for the oxygen, and then we get a total of 44 grams. So 73.88 grams of lithium carbonate, in other words 1 mole, is going to give us 44 grams of the gas, so 1 mole of carbon dioxide. We've got 100 grams, so let's go first to 1 gram, divide everything by 73.88. We need to divide the right by 73.88, and then to get to 100 grams, multiply up by 100, multiply right by 100, and we get 59.56 grams of the gas. So let's put that up at the top there. So now we need to do the same thing for the strontium carbonate. So again, now this time strontium is in group 2, and it produces the Sr2 plus ion, carbonate CO3 2 minus. The charge is balanced, so the molecular formula is simply SrCO3. And when we heat this up, it thermally decomposes into the oxide, SrO, and CO2, the gas. So everything balances here, the strontium balances, the carbon balances, we've got 1 each side, and the oxygen, we've got 3 atoms each side. So from the equation we see that 1 mole of strontium carbonate, when we heat it up, gives us 1 mole of the gas, the CO2. But we've got 200 grams of strontium carbonate, so we've got to find out how much gas that produces. So we need to know how many moles of strontium carbonate 200 grams is. So let's get the mass of 1 mole, and the molecular mass of strontium is 87.62 grams. Add on to that carbon 12, and 3 lots of oxygen, each oxygen 16. Adding the figures together, we get 147.62 grams. Now let's look at the molar mass of the gas produced. Again, the carbon is 12, oxygen 16, and we got 2 atoms of it, so 2 times 16, add everything up, and we get 44 grams. So from the equation, we got 1 mole, 147.62 grams of the strontium carbonate, producing 1 mole of CO2, in other words 44 grams of the gas. But we've got 200 grams, so let's first of all again go to 1 gram, divide everything by 147.62, so we get that, and multiply up by 200 to get the 200 grams, multiply the right by 200 as well, and a calculator will give that as 59.61 grams. So let's put that at the top. So now let's go to C, the beryllium nitrate. So again we need a formula, beryllium group 2, so produces the Be2 plus ion, nitrate NO3 minus, So we're going to need 2 of those nitrate ions, so we've got 2 minus to balance the 2 plus in the beryllium. So the formula is going to be BeNO3 2. Now, when we heat up a nitrate, such as beryllium nitrate, it's going to thermally decompose into the oxide and also nitrogen dioxide and oxygen. So those are the products we get. The nitrogen dioxide and the oxygen are obviously the gases. So now we need to balance this. On the left, the beryllium's balanced, we've got 1 atom each side. The nitrogen, on the left, we've got 2 atoms. On the right, we've only got 1 at the moment, so we need to put a 2 in front of the NO2, so that we've got 2. Now, if we look at the oxygens, we've got 6 on the left. On the right, we've got 1 in the BeO, a further 4 in the NO2. So we've got 1 plus 4, 5. And we need 1 more. 6, so we're going to have a half, 0.5 in front of the O2 so that the oxygen's balanced. So from the equation we see that the thermal decomposition of 1 mole of beryllium nitrate gives us 2 moles of nitrogen dioxide and 0.5 moles of oxygen. Now, we need to calculate how much mass that is, what mass of gas we've got. So first of all, nitrogen dioxide, 14 is the atomic mass of nitrogen, 2 lots of 16 for the atomic mass of oxygen. Add everything up, we get 46. So the mass of that will be 2 times 46, 92 grams. Let's go now to the oxygen. 16 is the atomic mass, and we got O2, so 2 times 16, 32. But we've only got 0.5 moles in the equation, so we want half of that. 0.5 times 32, 16 grams. So it should be thermal decomposition of 1 mole of beryllium nitrate is going to give us 92 plus 16, 108 grams of gas in total. Now, the molar mass of beryllium nitrate we need to calculate next. So beryllium has atomic mass 9. Nitrogen, we've got 2 atoms there, each with atomic mass 14. And the oxygen, we've got 6, and each has mass 16. So add everything up and we get 133 grams. So 1 mole, the thermal decomposition of that is going to give us 108 grams of gas, as we see there. So, but we've got 65 grams, so we go now to 1 gram, so divide everything by 133, do the same on the right, and multiply up by 65 to get the mass of gas for 65 grams. And if we use a calculator there, we get 52.78 grams, so let's put that up at the top. Finally, go to the barium nitrate, and the barium nitrate, barium group 2 again, Ba2 plus ion it forms, nitrate NO3 minus, and we got we need 2 minus there to balance the 2 plus, so the formula will be BaNO3 2. Now write the thermal decomposition equation, and again we're going to get the oxide, BaO, and nitrogen dioxide and oxygen. We see that we've got 1 atom of barium each side, so that's fine. The nitrogen, we've got 2 on the left. On the right, at the moment, we've only got 1, so we need to put a 2 in front of the NO2. Moving to the oxygen, we've got 6 on the left. On the right, we've got 1 in the barium oxide, a further 4 in the nitrogen dioxide. 1 plus 4 is 5. We need 1 more, so we must put a 0.5 in front of the O2. So it's now balanced. So for the equation, we see 1 mole of barium nitrate and again it should be thermal decomposition, sorry about that, produces 2 moles of nitrogen dioxide and 0.5 moles of oxygen O2. So let's work out the mass of gas we've got. It will be the same as last time, in fact, but let's do it again quickly. The molar mass of nitrogen 14 atomic mass, oxygen 16, and we've got 2 atoms of it. Adding up, we get 46 grams. We've got 2 moles from the equation, so multiply by 2, we get 92 grams. With the oxygen, 2 times 16, because we've got O2, that gives us 32, but we've only got 0.5 moles, so we need to multiply by 0.5, and we've got 16 grams. So again, the total mass of gas from thermal decomposition of 1 mole of barium nitrate going to be 92 plus 16, 108 grams of gas. So now we need to work out the mass when we start with 125 grams of barium nitrate. So again, we need to get the molar mass of that. So let's do it. Molar mass of barium 137.3 grams. And we got 2 nitrogens, so 2 times 14, 6 oxygens, so 6 times 16, 16 the atomic mass of oxygen. Add everything up, we get 261.3 grams. So that means that the thermal decomposition, once again, 261.3 grams of barium nitrate is going to give us a total of 108 grams of gas. Going to 1, so dividing everything by 261.3, we get that. And the question says we've got 125 grams of barium nitrate, so we need to multiply up by 125. Let's do it. And that gives us 51.66 grams if we use a calculator. So let's put that in now. So now we've got the 4 answers. We can see that the winner, just about, is B. That gives us the most mass of gas, so B is the answer there. So that's that. That's those questions. So again, I hope this has been helpful to you, and look forward to seeing you in the next video, which will be the answer to questions 9 and 10 in the series.